Welcome to Class 28 of our Intermediate Level Refrigeration and Air Conditioning course. On this occasion, we are going to study in detail the table of pressure and temperature of the refrigerant gas R422d. Before continuing, you need to know all the technical characteristics of R422d gas. A link to a video is appearing on the screen with all the details you should know before doing any work with this refrigerant. Let's start by saying that the refrigerant gas in a refrigeration cycle can absorb heat from the air in a room because it has a very low temperature. In the evaporator, the heat from the air passes to the refrigerant, therefore the air loses temperature, while the heat that was from the air remains in the refrigerant, but there is no increase in its temperature because the refrigerant uses the heat to pass from the liquid phase to the soda. However, there are refrigerants, which are made from the mixture of several gases, where there can be a small increase in temperature while its phase change occurs. This phenomenon is called refrigerant creep. On the screen we have the table of pressure and temperature of the refrigerant gas R422d.
True. If you are interested in acquiring information about tools to perform maintenance tasks in refrigeration and air conditioning, like a true professional of good quality refrigeration and at a very good price, you should watch the description part of this video. In addition, we also have complimentary, related information that will help you in your work.
As we can see in the table, we have two pressure columns, one corresponds to vapor or dew pressure and the other to liquid or bubble pressure. This occurs because the R422d has slippage. Remember that slip means that the temperature of R422d changes while it is evaporating, and this aspect must be taken into account when recharging with R422d. To take this slippage into account, we are going to carry out the following analysis. Thus, for example, for an evaporator temperature of 6 degrees, according to the table, there are two pressure values. Liquid pressure or manometric bubble equal to 80.36 Ig and steam or dew pressure of 70.60 Ig. At this moment the question arises, which pressure to select to work? The answer will depend on which part of the evaporator you want to achieve the selected temperature, that is, 6 degrees. For example, if you want to achieve 6 degrees at the inlet of the evaporator, then it means that at the moment the first bubble of vapor appears, the refrigerant being in the liquid phase, its respective bubble pressure must be present, then you would work with a low pressure in the evaporator of 80.36 psig. Since the R422d has slippage, even though it is 6 degrees at the entrance, this value begins to increase. Therefore, before leaving the evaporator, when there is simultaneously liquid and steam, the temperature will not be 6 degrees, but will be higher. Now let's consider the next possibility. If we want the 6 degrees to occur not at the inlet of the evaporator but rather at the outlet, that is, when there is pure refrigerant in the form of vapor, then we must work with the vapor or dew pressure, in this case with a value of 70.60 psi, and then again another question may arise, what pressure value is most recommended to work with? Well, in reality, it is more common to work with the dew pressure, that is, to reach the temperature only up to the outlet of the evaporator. However, at this point it is important to note that for 6C is the bubble pressure equals 80.36 psig and the vapor or dew pressure is 70.60 psig. So, in the case of working with an intermediate pressure, within these two values, we would be very close to reaching 6 degrees, not at the inlet or outlet of the evaporator, but approximately in the middle or in the middle of the evaporator. For example, taking the average between these values gives a pressure value of 75.48 psig. Although it is not exact, we can say that with an evaporator pressure of 75.48 Ig, we would be very close to reaching the temperature of 6 degrees in the middle of the evaporator. And on screen we have other pressure values that are commonly used with the R422D. Thus, for example, to achieve a temperature at the inlet of the evaporator of 0 degrees C, a manometric pressure of 64.7 psi G must be low. On the other hand, if you require the same 0 degrees at the outlet of the evaporator, then you must work with a low gauge pressure of 55.20 psi G. Thus, for example, to achieve a temperature at the inlet of the evaporator of -10 degrees Celsius, a manometric pressure of 41.70 psi G must be low. On the other hand, if you require the same -10 degrees at the evaporator outlet, then you must work with a low gauge pressure of 34.31 psi G.